Hey everybody, it's Mr. Baker talking from my house. I am recording myself here because I want you guys not to fall behind of the other three classes. I'm going to be out in the morning, but I'm going to be back in the afternoon teaching all of those classes. So for the two classes I have this morning, that's Core 4, Core 5. I'm going to have to do this. It's the next best thing to me being there so that you guys don't lose time compared to the other three classes. So what you're going to have to do is pay attention as best as you can. Because the substitute, if they think you're not getting this information, is going to have to stop it, and then you're going to be behind, and then you're going to have to play catch up tomorrow. And you're not going to want to do that because it's going to be just too much stuff. So hopefully this will work. You will listen. You'll open your books if they aren't already open. You're going to want to open to the first page of 2.1, and we'll get going. So what you see here is me. Every once in a while I'm going to make myself big, like so. Hello, if I need to make a big point or something like that. And then I can always go back and revert to talking about this and showing what's going on here. So every once in a while you're going to see me look at the screen or look at you. Hopefully all this works out. Yesterday we talked about light. Just a quick review. Light is energy that's made when electrons jump from one energy level to another. Oh, there I go. Nuts. I just realized that if I hit the highlighter, I disappear. So you're going to want to definitely know that electrons, when they jump from one energy level to another, that makes light. We talked about that with this little thing going up to here, and then back down. And when that happens, it emits a little piece of light. You're just going to have to know that. Okay, there I am back. Moving down to nuclear energy. I can't remember. I don't believe I went over nuclear energy with you guys, but I want to make sure that I do. Nuclear energy is energy in the nucleus of the atom. I'm going to disappear again because every time I do this I'm going to disappear. It's energy in the nucleus of the atom, and it keeps the nucleus together. There's forces that keep this nucleus together. You see, the nucleus is made of protons and neutrons, and the protons that are right here don't really like to be together in the nucleus. See, the protons are positively charged, and the positively charged ones don't want to be with the other positively charged ones, because remember, opposites attract and likes separate. So what keeps them all together there in the nucleus? What keeps them all together in the nucleus is this force, this energy that kind of squishes them all together, even though they don't want to be together in the nucleus because they're all positively charged. This energy that keeps them together is incredibly large, and if you were to be able to, let's say, shoot a well, you're going to lose me here again, but that's fine. If you were to shoot a little particle straight in, bang, this would go flying. You'd have particles flying out. You would release all that nuclear energy. All that nuclear energy would be released, and that's what makes a nuclear bomb, or that's what makes the beginnings of a nuclear reaction in a nuclear power plant that delivers nuclear energy to different people. I mean, an area or volume the size of my fist would make enough atoms that were you to explode one, it explodes others next to it, and then others next to it, and all these little things here go and hit other atoms, and then you've got this big nuclear reaction, and then that's what a nuclear bomb is. So when all of these eventually lose all their nuclear energy all at the same time, basically, that's a nuclear bomb. So it's a lot of energy in the nucleus of an atom, keeping it together. So we've got light energy, we've got nuclear energy. Let's find out about the third. Energy. I have to make, whoops, did I go too far? Yeah, okay. Chemical energy. Chemical energy is energy that's in between atoms, and it keeps the atoms bonded together. So it's in between atoms. We're not talking about energy now that is in an atom. We're talking about energy that's in between atoms, holding atoms together. So if this fist is an atom and this fist is an atom, what's holding these two fists together, what's holding these two atoms together, has a lot of energy. You have to put energy sometimes into holding atoms together and bonding them together. When you break those atoms, you release energy. This is what all fuel basically that we use is about. I'm talking, well, you can see it down here, batteries and food or any fuel or which includes gasoline for the car or wood. All of these things have chemical energy. And let's just take batteries for example. When a battery inside has chemicals, and the chemicals are bonded together using chemical bonds. If you break those chemical bonds, you release energy that then can make something work. Let's say your phone or a handheld video game or something like that that runs on batteries. All that's in those batteries are chemicals. When you charge those things, you plug them in, what you're doing is you're using the energy that comes out of the socket. It goes up through the wire into your phone, let's say, and it goes into the battery, and that energy makes bonds. So when you plug it in to charge it, it makes bonds. And then when you unplug it and you use it, the battery breaks those bonds, releasing the energy, and your phone works. Food. You eat food. The food has molecules made of atoms stuck together. Your body has the ability to take those atoms stuck together and break the chemical bonds. That releases the chemical energy. Your body uses that chemical energy to run itself. And so food is chemical energy. Batteries are an example of chemical energy. Not your car. You don't have a car, I don't think. And if you do, you should be driving. That's a no-no. But if you were to drive and have a car, you would put gas in it first. Gasoline is nothing but long strands of carbon atoms connected by chemical bonds. That's what gasoline is. And so when that gasoline goes into the cylinder and gets exploded and lit on fire, that makes the engine go, by the way. When that happens, that fire is just chemical bonds breaking and releasing energy. And that energy release, pushes the pistons, and then the piston, the engine goes, and then all of a sudden your car is going. So, wood is a final example. When you burn wood in a fire or something like that, all you're doing is taking the chemical bonds that exist in the... Oh, it's a phone call. Oh, God. I'm going to have to turn this down. Give me a second. Okay, it's off. What the heck was I? So wood is just a bunch of chemical bonds all stuck together. That's what makes up the wood. When you light that stuff on fire...
Hello, we are not available now. Please leave your name and phone number after the beep.
I don't think I want to hear this.
We will return you.
All right, then. Okay, good enough. All right, anyway. Wood. You burn it, you break those chemical bonds, and then energy is released in the form of heat and light, and you go, oh, that's toasty by the fire. Okay. Hopefully you understand chemical energy. It's stored in the chemical bonds, and it has the potential to be used. We'll get to potential in a while. Heat. Heat is another type of energy. It's also known as thermal energy. Heat is funny. I don't want to go too much into heat because it's hard to describe actually what heat is. But just know that you're gonna lose me here. Stop it. It's energy that's released when atoms in something jiggle and they bounce into each other. I keep using this picture and saying it's like a mosh pit, thinking that people might know what a mosh pit is, but I think as time goes by, you guys know less and less about what a mosh pit is. Basically, if you imagine this, when atoms are cold, they don't jiggle very much, and that's why they don't take up a lot of space. You know, cold things are very dense. They're dense because all the atoms are only jiggling just a little bit. Just a little bit. But if you put heat into them, if those molecules have heat, if those atoms have heat, they start to jiggle even more. Let me put myself on big. All right, they jiggle even more. And because of that, they take up even more space, which means the thing that's heating up is getting bigger. And you remember that from last year when you talked about, okay, hot things get less dense because they get bigger and then they rise. But it's because of the heat energy. You measure heat energy by how much the atoms are jiggling. That's really what heat energy is. Heat energy is the energy of jiggling atoms. So if they're only jiggling a little, not a lot of heat. If they're jiggling a lot, it's a lot of heat. That's heat energy. Nothing more than that. Oh, the mosh pit, yeah. People in the mosh pit have a lot of energy. And so they're all, and they're doing this, and they take up a lot of space. But there's some people that are outside of the mosh pit, and they're just kind of dancing like this. They don't take up a lot of space, and they're not using a lot of energy. So they're like the very cold atoms. But the ones in the mosh pit kind of doing this, those are the ones that have a lot of energy, if you want to think of it that way. If that's confusing you and you don't even know what I'm talking about, don't worry. Just know that it's jiggling atoms. Okay. Just checking on my time. All right. Electrical energy. Let's extend the page. Oops, not that much. Okay, electrical energy. Also known as electromagnetic energy. It's made when electrons from one atom jump to another atom. Remember way back, 10 minutes ago, when I talked about light. Light energy was made when electrons jumped within an atom, just like this. So this was light energy, chunk, and then back down. All of it happening in one atom, right here. But electrical energy is kind of like that, but different. Electrical energy is when when an electron from one atom jumps, but it doesn't stay in the atom. It jumps all the way to another atom and lands here and starts to kind of shack up right there. Well, what that literally is an electrical current. This electron jumping to another atom is electricity. Now, of course, this atom here has too many electrons. It doesn't like having too many electrons. So what is it going to do? It's going to bounce one of its electrons, to another atom. Okay? And it'll land here. And then this atom has too many electrons. So it's going to bounce one of its to the next atom. There's the nucleus. And there it is landing. And then this atom shoots another one to another atom, and so on. And what you see is this kind of movement of atoms down the line. This movement of atoms down the line is what we call an electrical current. An electrical current goes from one place to another place. And this electrical current is how electricity, let's say, gets from one end of a wire,